For number 18, we're just checking to see if these four equations are true. So looking at the first one, on the left-hand side you have a binomial, x squared plus 25, and on the right-hand side you're asked to take x plus 5 and square it. So in order to take x plus 5 and square it, you would have to write it twice, because the definition of an exponent, if you're squaring something, it's repeated multiplication. So x plus 5 times x plus 5. Hopefully from here you can decide whether this is true or false. If you expand x plus 5 and x plus 5, because both signs are positive, you would end up with a trinomial. The trinomial would be x squared plus, how do I get the middle term? You add 5 and 5, which is 10, so 10x's. How do you get the back term? You multiply 5 and 5, so you get 25. So this is definitely a no. The next one kind of is the same thing. If you look at the left-hand side, this time you have 3 terms, but the right-hand side you're multiplying x minus 4 times itself. So if you multiply x minus 4 times x minus 4, again I'm going to use a shortcut. I know x times x is x squared. How do I get the middle term? I add negative 4 and negative 4, which is negative 8 x's. And how do I get the back term? I multiply negative 4 and negative 4, which is 16. So this second equation is a true equation. Let's go down to the last one, because I do need the room here for the third one. The last one, hopefully you agree, we don't need any work really. So if you have x minus 6 times itself, would that be the same as x minus 3 times itself? Well, if you change the number inside from a negative 6 to a negative 3, that would definitely give you a completely different value, so that would be a no. Alright, so for this third one down, there's two ways you could do it. You could expand 3x plus 6 times 3x plus 6 and distribute. You can also, on the right-hand side, expand x plus 2 times x plus 2 and then multiply all three terms by 9. However, this left-hand side, I want to focus on that. So if I expand, it would be 3x plus 6 times itself, 3x plus 6. And how can I make it look like the right-hand side? Is that even the right-hand side? Well, if you look inside, notice that 3 and 6 can be divided by a common factor. I could divide both of those by 3. So if I divide both by 3, technically what we would do is we would factor out the 3. And so what would be left inside? X plus 2, if you divide both by 3 or factor by the greatest common factor. And the second parenthesis was identical, so you're factoring out a 3 and you're left with x plus 2. So in the end, I have these two 3's, and coefficients always go in the very front. So multiplying those together, you get 9. And then you have x plus 2 times x plus 2. And if you have repeated multiplication, you can use an exponent. So it's 9 times x plus 2 squared. So that third equation was true.